Aloha, Richard Halverson here. This is ICS211, and in this video, I'm going to talk about heap sort. So let me share my screen. And we just finished in the previous video, we talked about heaps and defined it and show how a heap it can be represented very nicely. It's a binary tree. It can be represented very nicely in an array. That's because it's a complete binary tree. And then this section, we see how we're going to use the concept of a heap to create a sorting program, an O of n log n sorting program. And so heap sort is a sorting algorithm that takes advantage of the max heap properties by repeatedly removing the max and building a sorted array in reverse order. So an array of unsorted values first must be converted to a heap. The heapify function does that. Heapify operation, and then it starts pulling the nodes off one by one, sticking them on the end, exchanging them with the last one, reheaping, pulling the top one off, exchanging it with the last one, and it keeps on going until it's a fully sorted array. So here's an original array. It's not a max heap. We heapify it by you can go through this and see the process of it. Heapifying, make sure you understand that. You can see that given a binary tree of n nodes, the largest internal node is indexes n over 2 minus 1. Right. Okay, so so this shows the heapify operation. Let's take a look at that. See what it looks like. We start out, we have an original array. It's not a max heap, and then we start at the very satisfy the max heap requirement. We're at 2, so we have to put 98. We have to exchange 98 with 55, and we have to. That's good. There, this one exchanges, and then that one exchanges with that one, and then we're done. Okay, now it's a heap. All right. So this is the heap sort begins by heapifying the array into a max heap and then initializing an end value to the size of the array minus 1. Heap sort repeatedly removes the maximum value, stores that value at the end, and decrements the end index. The removal loop repeats until the end index is 0. So if we can see what this looks like, we start out with a heap. That heapifies it. And then we pull the top one off, exchange it, reheapify. Pull the 88 off, replace it with the 49, reheapify, and we keep on going, each time pulling the top one off and sticking it at the end. This is the until finally we're done. All right. So make sure you understand that. This is the heap sort algorithm. First we heapify, and then we swap. We swap the top node with the position in the array that's in the array where we are building the final sorted array. That's this right here. All right. Okay, so let's do a challenge here. Heapify into a max heap. Oh, okay, gee. Oh, let's see if I can do this one. Heapify into a max heap. Let's see, this should be the heap of that two. This one should be the heap of that one, and this one should be heap of that one. Okay, so we start out by making 70 64 and 70. Let's see. All right, so I'm gonna try to do it this way. I actually haven't done any of these yet, so I'm gonna try to do it this way. I'm gonna first of all I'm gonna put 82. It's supposed to be commas, right? Okay, 82, comma 78, comma 33, comma 54, comma 64, comma 52, comma 70. So this is what we start with. And then these are the children. These are at the very bottom. This is the parent of these two. And so I think the 33 would be exchanged with the 70. Yes. So the 70 would go here, and the 33 would go here. And then we have the 78 is the parent of 54 and 64. That's fine. And then we have 82 is the parent of 78 and 70, and I think that's fine. So this might be the max heap. Let's see if it is. Well, it is. I'm going to do the next one. I'm not very confident in my ability here, so I'm going to do the next one. I think yours might be different. Heap sort has heapified an array. Okay, we have this heapified array and is about to start the second for loop. What is the array after the first iteration of the second for loop? All right, so I'm gonna do the same thing as I did last time. What would happen if we do this? Does this work? Copy, paste? No, it does not work. Okay, so we have this, the array looks like this right now. And it's a heap. And so the second for loop is where we start with the iteration of the first for loop of the second for loop it swaps the number at the very head at the top with the number at the very bottom, and then it percolates down the number that was put at the head. Yeah. Okay. So it puts the 96 here, 96, and it puts the 28 here, 28, and then it percolates down. It's going to compare this one with this one and this one, and it's going to take the top one and put it here. So it's going to make this be 95 and this be 28. Okay. And then it's going to look at 28 and its two children, which are these two. And it's going to take the biggest one and trade places with it. So the 28 is going to go here. And the 59 is going to go here. And then it's going to take the 28 and it's going to compare it with its two children. And I don't think it has any children because this one has these two children. This one has these two children. And this one has this as a child. So I guess it's in its proper place. Do I have any stray commas or anything that might mess me up? This. Okay. Let's see if this is right. Oh. $92, $59, $80, $28, $11, $10, $96. That's what was expected. Do I have too many spaces in here? I think I do. 10, 11, 28, 80, 59. So anyway, I think I got the right answer, but I must not have the spaces. There must be too many spaces someplace. So what happens when I do this? It asks me the same thing again. All right, just to prove it, I'm going to do this again. 94, comma, what is this? Yeah, right. 94, comma, 53, comma, 64, comma, 34, comma, 43, comma, 38, comma, 36. Okay, so the first thing it's going to do, it's going to switch this one with that one. So this is going to be 94. It's going to be 94. And this is going to be 36. And then it's going to compare this one with these two. And it's going to trade places with the 64. So now the 64 becomes 36. And this becomes 64. Okay, and then the 36 is going to look at the 38 because that's the only child it has now. It's just the 38. And those two will trade places. So this will become a 6. And this will become an 8. 8. Now, I think this is right. It is. Okay, I'll leave the last one for you. All right, section 20.5. This is the heap sort program, and so you have to go through and make sure you understand this heap sort program. This is the percolate down from max heap. And again, this looks at the two children of the node that's coming in. I goes from 0 to 1, looks at the children, and it finds the max value of the 3. If the max value of the 3 is equal to the node, that we're percolating down, then we're done. Otherwise, we trade places with the node that's the max, and we keep on percolating down. That's percolate down. This is heap sort. So all we have to do. Well, anyway, so this is the heap sort program. And so go through this and you can run this. What happens when I run it? Well, that's nice. What is the heapified array contents? Can the print line be inserted in the heap sort method to display the heapified array? Where can a print line statement be inserted? Where can a print line statement be inserted in the heap sort method to display the heapified array? Percolate down. Heap sort. Heapify numbers in the array. I guess you could put it right here. Right here, we could show the heapified array. So you could do this. What is this? Do something like that, I guess. This is the parent of these two. This is the parent of these two. This is the parent of these two. And this is the parent of these two. Yes, that looks right. And then how do I make it descending? I think I make it instead of ascending. I think I would just do something like here. Let's see what this does. All right, ascending order. Okay, so I have taken you through all of the heap sort chapters, except for, did I cover, I guess I didn't cover this priority key abstract data type. I guess you got to click through this to get these points. And oh, there's a challenge activity here. Assume the lower numbers have a higher priority and that the priority queue currently holds that. Where does NQ add an item? Well, I tell you what, I'm going to leave this section for you to look at. Priority queues with heaps. So why don't you read this section and do these challenge activities, and that will finish up chapter 20. And that just leaves 21 left. In the meantime, you are ready to go to do lab 5. What you're going to do in lab 5 is you go back to your lab 3 and you're going to add heap sort to your lab 3. All right. Anyway, so very good. Hope this helps. Thanks for watching.